You every single time, but occasionally I will. And when you get out of this class, you're going to be so good at Excel. You're going to be an Excel master. You're going to be doing all sorts of great things. And so it's a painful process, but becoming good at something always is. So I appreciate that you submitted your homework. The next one is due on Friday of this week. So that's the present worth analysis assignment. I'll post that immediately after our class lecture today. Looking a little bit further into the future, your first midterm exam is Wednesday the 30th. So we've got about a week and a half for that. Today we're going to be moving on to a new part of the course, and this is where we move from just calculations to analysis. And you can see that I have the word analysis bolded here just to emphasize that we're doing something new now. The whole point of this course is decision making. And so in analysis, what we're going to emphasize is comparing alternatives, where you have an option A and an option B, and they're different in some way. And without economic analysis, maybe we wouldn't be able to compare them in an accurate manner. But with economic analysis, we can go through and use our tools to find out which one is the most profitable, which one is going to minimize costs, maximize profits. And so the first of the methods that we're going to learn today related to analysis is called the least common multiple method. So before we get into that, are there any questions related to just these announcements? All right. Now I got a couple of good questions over the weekend related to the homework, by the way. And if we have any extra time at the end of the class today, I'll go through and show some additional kind of streamlining tips for the homework problem number 2. That's the one that I gave you a demo on at the beginning of class on Friday, but I think I may not have taken that demo quite far enough, because there is a way to apply your formula down through row after row after row that simplifies it quite a lot compared to typing in the equation each row as you go through that. So if we have some extra time, I'll give you that demonstration. But let me just make one other suggestion. Sometimes I'll be out on the weekend, I'll be at the park or on the trail or, away from the computer. And, if I've got an extra moment here or there, I might check my email. And if I get a homework question from you, it's harder for me to answer the question if it's something like, on problem number 2, should I assume repeatability? Like when I'm out on the trail, I don't remember exactly what problem number 2 was. So if you want to arm me with some additional information to help you answer those questions, you could take a picture of the problem statement, or like, what are your calculations so far? So if you give me additional information about what you've tried and specifically which question you're asking about, then I'll be able to answer more often than just the times that I'm in front of my main desktop computer with my notes and my textbook. So just wanted to put that out there, that if you make your questions detailed and provide the extra background, there may be times that I can answer you a little bit sooner. And I see KC noticed my trail videos on YouTube. You're going deep to find those. I posted those a long time ago. All right, so just a couple of other preliminary announcements. Remember, I already announced this before, but I wanted to reemphasize that if you're thinking about doing an internship or getting ready for a co-op, the Office of Career Education is sponsoring a job prep fair from 11 to 3 on the 30th. You're going to be busy thinking about your exam that day. But then also on October 1st. And that is, I think, immediately before the Virtual Career Expo. So that's to get everybody ready for the Career Expo. They have the job prep fair to get your resume polished up and practice some networking and interviewing type skills. And then the Engineering and Science Career Expo is on the 13th of October. So they're going to try and have some employers who are interested in hiring engineering type people over the summer. So, all right, decision making. So we're moving on to a new phase of the course where you're going to have a lot of different options. And this kind of interesting diagram from the book is meant to conceptualize the process of, where do decisions come from? How do you decide whether to pick a Dell server versus an HP server? Or, You know, when you make the decision that you're going to get a new concrete vibrating system, you know, why is that? So first of all, decisions are generated when you have a problem. And so a problem may arise from an administrative mandate where they're saying we're going to do a new thing or go in a different direction. It can be generated from a lot of different things, from cost estimates when suddenly you're surprised by how expensive a piece of equipment is and now you're looking for alternatives. It could be the experience of someone out on a job site recognizing that what you're buying now isn't working and so a new alternative is required. But all of these different factors will lead to proposals, and proposals meaning something like, I propose we buy a new asphalt smoothing machine. And then the first step is to sort the proposals into those that are viable or not viable. And so viability may depend on the purchase price and how much capital your company has access to in the lending markets. Viability might be whether the technology that you want is maybe only available to your competitors. There can be, for example, exclusive licensing agreements that tie up one manufacturer to one supplier to one company that uses their products. And so, you know, there can be a lot of things that make some projects not viable, but of the projects that are viable, we can sort them into two different broad categories. And one are mutually exclusive alternatives. And mutually exclusive means that you only need one of the items to move forward. So you're not, if you need transportation, for example, you personally, then you can buy, let's just say to keep it simple, a Chevy, a Tesla, or a Volkswagen. But you're not going to buy all three. You only need one car. And so those are mutually exclusive alternatives. And one of the options among the mutually exclusive alternatives is do nothing. And so you can see here DN, that stands for the do nothing alternative. And it should always be examined that maybe you should continue riding the bus or getting a ride from a friend or walking or riding a bicycle. So the mutually exclusive alternatives means that you only select one. On the other hand, independent projects are those where you can accept any of them that are good, that will be yielding a return above the MAR. Remember, minimum acceptable rate of return. So independent projects, you can pick as many of them as are economically justified. Now, the next stage of this analysis process is that sometimes projects will generate a profit, and those are revenue alternatives if there's going to be both costs and revenue from the item. But sometimes, especially in public works type projects, if you're going to be paving a road or if you're going to be collecting garbage or building a hospital, those things can be done at a loss, or there's not enough revenue to justify the alternative, but it's still in the public interest. So take, for example, Ritter Park. Probably everybody's been to Ritter Park or is familiar with it. It's a beautiful place. It's really, really nice. But they don't generate any revenue from that. They don't charge admission to Ritter Park. There are certainly costs, and so they're doing that project in spite of the fact that it's not profitable. So we'll talk more about cost alternatives in a later phase of the course. But in the case of revenue alternatives, there will be a decision criteria. How do you know which alternative to select? And the decision criteria is choose the option that maximizes profit. And so we're going to talk about today a method that allows us to identify the alternative that maximizes profit. Before we move any further, any questions about this diagram specifically? All right, well, let's go over a little bit of terminology just to make sure we're on the same page. Now, I've already talked about mutually exclusive alternatives, and that's where you're only picking one, in contrast to an independent project where you can choose as many as are suitable and as many as are profitable, as many as you can go borrow money to finance. The do-nothing alternative should always be examined, and too often it's not. Too often administrators or managers of a company will get it in their mind that, I've got to do something. I've got to make my mark. We have to implement a change, just because if we're not doing changes, then why do I exist? Why have a boss if you're not changing something? And so there's, unfortunately, too often an administrative bias in favor of change, when sometimes if it's not broke, don't fix it. So the do nothing alternative should always be examined, and I really believe in that. And if you see my car, you'd know it. It's rusting, it's old, it's almost 20 years old, but it still runs, and I own it. I'm not paying a fee for it. So the do nothing alternative sometimes is economically rational, that's for sure. The revenue-based and cost-based projects differ in that in a revenue-based project, there's a possibility that the income that's generated will justify the expense of obtaining the equipment. And in contrast to that, a cost-based alternative is one that may have public benefits, but it's not evaluated simply on the basis of its revenue. Okay, decision criteria. This is so important for you to understand what the word decision criteria means. And on exams, when you say one thing is better than another, you also have to tell me, why is it better? Like, how did you decide? What was the criteria that you applied for making the decision of option A versus option B? So in present worth analysis, what we're going to do is we're going to take a cash flow diagram. So that's revenues and costs over time, and we'll discount it to the present using the minimum acceptable rate of return. And remember, that rate of return may be based on a policy decision from managers. It may be largely based on the cost of obtaining capital to finance a project, and it could also just be based on the past experience of the company in knowing how profitable projects are in your industry. Now, if the projects are mutually exclusive, then the decision criteria is select the project with the highest positive present worth. So if you have two different cash flow diagrams, discount everything to the present, pick the one that's the biggest number at the present, the most profits. And if the projects are independent, meaning you can choose more than one, then you'd select all of the projects that have a present worth greater than or equal to at the minimum to zero at the minimum acceptable rate of return. So the MAR means it is acceptable. So even if the present worth discounts to zero, what that means is you're going to be making a profit rate that's equal to the MAR. If it's greater than zero at the present, then that means you're going to make the MAR plus additional profits. And you'll see that when we work a few examples today and in coming classes. I'll try and emphasize what it means, like what's the real world implication of this present worth. But this is the decision criteria, and whenever you solve a problem, whether it's an in-class exercise or homework or an exam, you choose the best option and you say what to do, and then you also say what criteria did you apply, like how did you know what should be done. All right, so just as a practice, before we talk about this next slide, let's take a look at the in-class exercise for today. We have a situation where we're going to be comparing two alternatives. We're going to be comparing two excavators, one made by Mitsubishi, the other made by Hyundai. The Mitsubishi excavator has a larger upfront cost. So you see it costs $250,000 compared to the Hyundai only costs $205,000 today. And I guess because it costs more up front, then that means that the Mitsubishi has a lower maintenance charge on an annual basis. $20,000 a year for maintenance versus $22,000 in maintenance. There's also differences in the fuel cost from one to the other. And the Mitsubishi must somehow be more efficient or productive because we're able to have a higher revenue with the Mitsubishi excavator than we can get with the Hyundai. And then the end of life salvage value is different between the two options. And so just to visualize what's going on here, I'd like you to start off by drawing a sketch of the cash flow diagram. And I suggest that you should draw each component. And what I mean by component is don't combine all of the arrows together. Don't make a net cash flow diagram. Make a cash flow diagram that includes all of the pieces for both Mitsubishi and Hyundai. And then once you have the cash flow diagram set up, use present worth analysis. So that means discount both of them to the present and then apply the decision criteria. So choose which option has the highest non-negative present worth. And then that's the alternative that should be selected. This is mutually exclusive. We're only going to pick the one that has the best present worth. It says to use I equals 10%, and I think the 10% table is here on the second page if you've got that printed out. Let me copy it and bring it up onto the other screen as well in case you're just working from the screen and don't have it printed out. All right, so let me pause for a moment and give you some time to, number one, sketch the cash flow diagram, and then number two, take the present worth amounts, take the amounts that are in the future to the present. All right. Well, at the very least, you should have the cash flow diagram sketched by now. So let me bring that up on the screen. And so to compare these two options, what we've got is the Mitsubishi and the Hyundai. All right. And the Mitsubishi has an initial upfront cost of $250,000. And then you can see that each year we have a revenue of $95,000. And so that's an annual series in the amount of $95,000. And then you can see here is our future, single future value as a salvage. That is in year 8. And then each year we have both the maintenance costs and the fuel costs. And so kept separately, it's $20,000 and $32,000. Now when you actually do the calculations, then it's okay to find the net amount. So when you do the calculations, you're going to find P given A for the resultant annual series. And that annual series is going to be $95,000 in revenue minus $52,000 in costs. And so what does that leave you with? $43,000 a year. The mental math sometimes isn't what it ought to be. Yes. And then you'll also have the single future value that you have to discount to the present. So when you think that you've got the correct present worth of Mitsubishi and Hyundai, feel free to type that guess into the chat box and I'll let you know if you've got the right amount. Because what we're doing in part 2 is find the present worth of both cash flows. Find the present worth of Mitsubishi and find the present worth of Hyundai, because we only know which one is better once we find the present worth of each. We can't tell until we discount all those future revenues and take them to the present. You know, the money has to be in the same year to know which one is better. Well, in case folks are struggling, let me give you an idea of how we do this one. So Mitsubishi, we've got $250,000 that's already at the present, and then the net revenue for each year is 95 minus 20 minus 32. So we've got $43,000 each year. And we want to find the present of that. That's an annual series right now. And so we will multiply that amount by the P/A factor that we get for the 10% table, n equals 8. And you can see below that I've substituted in the factor that we should use. So if you go to the table and look it up, The factor is 5.3349. And then there's 55,000 out there by itself in the future. And so that's a find present given future analysis we're going to apply. And if you look up the factor table, 10%, n equals 8, P/F, then you'll get 0.4665. So those numbers come from this factor table, 10% factor table. Okay, so you can see that 250 was already at the present, and that was a cost. And then here's the present value of the net revenue, $229,400.70 is the net revenue taken to the present. And then here is the present value of the salvage. The 25,000 is the present value of the salvage. So the present worth overall of the Mitsubishi alternative is $5,058.20. So what that means is that if your MAR is 10%, you're going to make the MAR plus some additional profits on top of it. So it doesn't mean that your only profits are $5,058. It means that your profits, when discounted to the present, are 10% plus an additional amount. So if you were borrowing the money for this project, let's say that that original $250,000 was money you got from the bank. You could pay the bank their 10% interest and it would still be profitable on top of that. So, if that 10% was going to some other organization, then your share of the profits would be $5,058. But if you had self-financed, then the rate of return would be 10% plus a little extra. So that's the Mitsubishi alternative. We do the same thing, same kind of technique for the Hyundai alternative. And so you can see the Hyundai has the 205,000 is already at the present. So it doesn't need to be converted. We don't have to multiply it by any factor because it's already at times 0. The net revenue is $32,000 each year. So again, we use the same factor because it's still 10% and it's still n equals 8 and it's still find P given A. Same factor for the future salvage value. It's just that this time the salvage value amount is a little bit less. And altogether, the Hyundai option is negative. So we should select the Mitsubishi alternative because it has the highest present worth when discounted at the minimum acceptable rate of return. So you can see that I've got the answer. I've got the numbers for both, but it's not just the numbers that answer the question. The question is, which alternative should be selected? And the alternative that should be selected is Mitsubishi, and I'm mentioning the decision criteria. It has the highest present worth, and so that's why I selected it. Any questions about this example? All right, well, let's talk about repeatability. Sometimes, in the example we just worked, in this example, it was a little bit easy because they both lasted for 8 years. The Hyundai lasted for 8 years, and the Mitsubishi lasted for 8 years. But sometimes equipment doesn't last for the same number of years, and it becomes a little bit challenging to compare them if, for example, option A lasts for 6 years and option B lasts for 9. And so you can't just take it to the present and compare because they have a different service life. And to compare alternatives, you have to have an equal study period. So unless we do something to make the study period the same for both option A and option B, then we can't accurately compare the two alternatives. So we're in a bind. This will solve it. Now let me flip back and forth between the previous slide and this one so you can see what we've done. So this is the original, and this is how we solve the problem. And so what is going on here between the original and this solved the problem type cash flow diagram. You can see that what we've done is we've repeated them. And the least common multiple approach gets its name from what you want to do is repeat both options the fewest number of times that they both terminate in the same number of years. So if we repeat option A 3 cycles, that will get us to 18. And if we repeat option B 2 cycles, then that will get to 18. Now, it's not always going to be the case that you're given a cash flow diagram that shows how many years you should repeat it to. Like even if option A had only showed you years 0 through 6, you could still use repeatability. So I provided this long cash flow diagram just to make the room for what I was going to do, and that is to repeat them. So, but now you got the general idea. The general idea is that we repeat the cycle. What we're saying is that we're going to use option A, this equipment. We're going to use it, and then when it's worn out, we're going to buy it again. But look, we buy it at year 6. We don't buy it at year 7. And that is because if you bought it in year 7, then you'd have a gap year where there was no revenue. So we want the revenue to be continuous. That's to say, we want the equipment to be ready when the old one wears out. And option A, at the end of the 6th year, that equipment is worn out. So if you bought it at year 7, then that means you'd have a full year where the equipment wasn't being used. So you need to buy the item again right at year 6. So that's why I have it at 6 and 12. And so then the cycle terminates at 18. So we have a continuous and unbroken access to the equipment over the entire 18-year period. The revenue comes in during the 18-year period. Same principle is true for option B. We have to buy it in year 9, because if we bought it at year 10, then the revenue wouldn't start till 11. See, the revenue starts after you purchase the item. So we need to buy it at 9 so that it's ready to use through the 9th year, and we get the revenue at the end of the 9th year. All right. So the least common multiple approach says repeat both alternatives so that they terminate on the final year, and then discount everything to the present and choose the alternative that has the highest non-negative present worth. So we're applying the same decision criteria. It's just this LCM approach is kind of a tool that allows us to make both alternatives terminate at the same time. Okay, so any questions about that? All right, now on the conceptual side of things, this assumes repeatability. So what that means is we're assuming that the item can be purchased in the future and that it will have the same useful life and it will generate the same revenues. So in other words, if you notice, the item costs $11,500 now and also $11,500 at year 6 and at year 12. Well, maybe the cost is going to be going up. So when you're applying this approach in the real world, sometimes you may need to use inflation to give you an idea of how much the item will actually cost in the future. So unless specific information is given, you can just apply and assume the repeatability, but I want to let you know that that is a built-in assumption, is that these things can be purchased and used again. And if not, then you need to make manual adjustments. And the main question is, will the revenue and the costs be the same in the first cycle and in the second cycle? Sometimes they will, sometimes they won't. All right, so here is that same cash flow diagram. And we want to compare these two alternatives, discounting everything at the 4% interest rate. And I think the 4% interest rate may not be on the what you've got there. Let me find it from another slide and I'll paste it onto the screen so that you've got access to that. I know I've got the 4% here somewhere. 8%, and I suppose I may need to scan it to bring it up on the screen. All right, well, here is the in-class exercise. The first thing that you need to do is sketch the cash flow diagram. And so sketch that repeatability, same as I just showed you. And remember that you need to purchase the item so that there is a continuous and unbroken string of revenue over the entire study period. While you're sketching the cash flow diagram, I'm going to track down the 4% table so I can bring it up on the screen for you to have as you're solving this example. All right, let me show you what we're doing here. All right, so we have a cash flow that okay, so we need to repeat it. I don't have the repeatability sketched. Well, I guess I've kind of already showed you what the repeatability should look like, right? The repeatability should look like this. So the key thing to remember is that you're not going to buy the item again in year 18 or down here for option B. Because if you bought it again, then what you're doing is you're entitling yourself to all the revenue beyond year 18. So we want our study horizon to be 18 years for both items, and then that's it. No more continuance beyond that. And so for this, what we need to do is, let's see, what's the best way for me to display both while we're going through the solution? So let's look at the cash flow diagram for option A. All right. So option A has 11,500, and it's the arrow down means it's an outflow, so that's the negative sign there. It's already at the present. And then we're going to combine it with the equivalent value of the annual series of 5,000. So $5,000 is repeated 18 times to get it so that both cash flow diagrams line up. So we're doing find P given A at 4% interest and N equals 18. Okay, so that factor when I go to look it up is 12.6593. So that's the factor that comes from this lookup. And we're multiplying it by 5,000 because we want to convert the ongoing repeating 5,000 into a single amount that exists at the present. And so both of those are at the present. Now we have to take these individual future amounts. And so there's this amount in year 6 and then another amount in year 12. And so you can see I'm doing a P/F. So find the present for a future at 4% for 6 years. And then a similar thing for 12 years. It's just going to be a different factor. The N equals 6 is a higher factor than N equals 12 because it's not discounting as many years from the future to the present. So option A is worth in total $35,525 because that's the value of the revenue. The $63,000 combined with the 3 times that we have to purchase the item. The time we purchase it at year 0, the time we purchase it at year 6, and at year 12. And so the present value of those future expenses is less. So that's why it's not 11,500. It's because we find the discounted equivalent of 11,500. All right, now the other cash flow diagram And let's look at option B. Maybe I can bring that up on top. Okay, option B. So there's already 16,000 at the present. So here I've put that at the end, the minus 16,200. So I'm going to find the present value of the 4,100, the present value of the 16,200 that I am purchasing at the second time at year 9. So the minus sign here is where I'm accounting for the fact that it is a cost rather than a revenue. So the present worth is going to be the present worth of the revenue, 51,000, and the costs, combining it together, 24,321. And so then the decision here is option A should be selected because it has the higher present worth compared to the two alternatives. All right, so this is something that at first maybe feels unfamiliar, but we're going to continue to practice this in the in-class exercises, and you're also going to get practice on the homework assignments. So if it's frustrating and confusing in the short term, don't worry. We'll get it. You're going to figure this out. We'll continue talking about how to deal with different useful lives with a couple of additional tools in our lecture on Wednesday. So that's all the time that we have for today. Let me just refresh your memory that the next homework assignment will be due on Friday of this week, and then Wednesday of next week is our first midterm exam. All right, that's it. Hope you have a great day.